Welcome back. We are discussing about some specific topics under environmental engineering. In this video, we'll be discussing on the water quality significance. Everybody requires water, and the most important thing is when we talk about water, its quality is also important because we are using water for different purposes like drinking, cooking, washing, irrigation, construction, and industry requirements like that. So, what are the things we have to consider, and what is the role of an environmental engineer when we talk about water quality systems or water supply systems? That we will discuss. Along with that, we'll try to see what are the various components of water supply systems and some typical treatment systems which we normally used at the community supplies as well as at the household usage. Now, let us look at this importance and necessity of protected water supply systems. So, as I mentioned, people depend on water for drinking, cooking, washing, and other domestic needs. Now, you see in these pictures, here the people you can see they are using this water for washing purposes, right? Clothes washing. And here you see the area is completely unhygienic, but still they are collecting water from the hand pumps. Now you see this water is completely dark and muddy, but still they are collecting water for their domestic needs. And this boy is drinking water, and you can see there are a lot of sediments here, which is there in the glass. That means the quality of the water is more important here. So water supply systems must also meet the quality as well as quantity requirements. It's not just the quantity, whether it is adequate or not. At the same time, quality is also important here. So there are a lot of impurities. There are physical impurities, chemical impurities, bacteriological impurities. When we are using this contaminated water, it will lead to waterborne diseases due to bacterial contamination and adverse health impacts depending on your physical or chemical impurities. So treated water should be available in abundance to the users who should have that with the easy access. And there are a number of treatment systems. They are varying from community usage to the household system. That also we'll try to look in these videos. So now let us see these pictures. The role of environmental engineer in water supply systems. Let us quickly look at the simple aspects. First of all, an environmental engineer, when he was dealing with all the water supply systems, he should estimate the water demand because water demand or water requirement will be there for a number of purposes, like a domestic purpose, commercial purpose, then institutional purpose. I mean, institutional means industry requirements, then public water requirements, all such type of things are there. Some losses also will be there. So there are some calculations, thumb rules. Based on that, he has to estimate the water demand for that particular locality, depending on the proximity of that particular area in with regard to the future. And then identify the appropriate water source to cater the needs of the community. Once we have that water demand, then we should identify that. First of all, these water systems, they will be designed for a specific period, maybe 30 to 40 years like that. So what is the population, expected population at that particular time, next to 40 to 50 years? So that calculations must be made. So that is done through some population forecasting methods. Once we know the water demand of that particular locality, we multiply that with the population for the design period, we will get the total water requirement. Once we get these two, then we have to identify a particular source of water which will be available to that community throughout the year, because there will be a dry season and wet season, a rainy season and summer season. So during all times of the year, so that water should be available. So you should identify that appropriate water source. And beyond that, when the quantity of water is identified, source is identified, now we have to look at the quality parameters. Which are the parameters are there in that particular water? Once you identify that, then there should be a proper treatment systems to treat this the water quality. So environmental engineers should do these things. So you should determine the water quality parameters. You should design and identify the appropriate treatment, and you should design and develop the water distribution system to transport water from the source to the consumer. Not only the treatment system, and the water should reach to the consumer from the treatment plant. So from the treatment plant, it should reach to the consumer means there should be a pipe network system. There should be a series of overhead tanks to supply the water through gravity. All these things must be designed by environmental engineer. And once these things are ready, then his role is fulfilled. And beyond that, there should also be some maintenance things. So you are having a water treatment plant, and whether the plant is functioning properly or not, that also should be checked. So there should be a mechanism to monitor that performance of water treatment plant. And there's periodically you should also check the water quality, whether meeting with the required limits or not. So depending on that, they should make some arrangements in the working of the treatment units. And also the distribution systems, there should also be regular monitoring the leaks. If there are anything are there in the pipeline, that should be checked there. And then if there is any problem in the overhead tanks, the water is not reaching properly, that also should be checked. All such type of things. These are all the various roles to be performed by environmental engineering water supply systems. If you look at these pictures, the first picture shows the intake. So there is a water source here. It can be a river. Now you're having the pumping, there a well is there. The water is collected through the well. And then you're having a pump and water is pumped through the well to the outside for treatment plant or to distribution systems. And second picture, this is all about the treatment units, number of treatment units coming out in a water treatment plant. And this is the overhead tank, which is a part of water distribution systems. Now let us see what is the various component of water supply systems. The components are identified as a collection, transmission, purification, and distribution system. What exactly are those? As I mentioned, first of all, there should be a source. This source depends on the water demand and population calculations. The adequate water must be available at the source. Now, this is the intake. Intake is nothing but the collection point from the source. So here, this is the intake point. So this is nothing but collection system starts from here, from the river. And then there should be usually there should be a pumping system or a piping system to reach to the water treatment system, water treatment plant. Usually the rivers are at low level compared to the ground level. So you need to have a small pumping. So this is piping and pumping, everything comes out to the transmission systems. And after that, the water goes for treatment here. This is a treatment plant. This is the third stage of the water supply system. And then it should reach into the community through different pipe networks or overhead tanks, something like that. So now this is the community supply. Right? So your water supply system ends here. So this 1, 2, 3, 4. This is the water supply system. And the other thing which is now hidden in this thing is whatever the water comes out from the usage by the community will end up as a wastewater. We are calling as sewage, domestic sewage. And then it will be treated here at a effluent treatment plant like we are using a water treatment plant, raw water treatment plant here for the raw water. After the effluent treatment, the treated water will be discharged outside, and usually when the water body is there close to the proximity, then we'll discharge that water into the water body. So this is a water outlet, right? So these are all the four systems of the components of the water supply systems. Now, if you look at a community water treatment plant layout, now this is what I mentioned. This is a source. It can be lake or river, any surface water body. Now you can see this water is at low level and compared to the ground level. So the water is collected through intake pipe. This is coming out through intake tower. Then you're having a small pumping system here, from pumping system here. So that now this is all about the treatment plant. So this is the collection works, and now this is your transmission system. And now you see this is all about treatment system. A number of treatment units are used here up to this. Up to this, this is how treatment systems are there. There are some coagulation, sedimentation, addition of alum, and some sand filters, some chlorination, everything is there. Once the treated water is completed here, it should be pumped to overhead tanks for community supply. Why you are pumping to overhead tanks? Because water is stored at a higher elevation. It can easily supply by gravity. Suppose occasionally we may go for some ground level reservoirs also, depending on the requirements at the locality. So now to lift this water, we used to go over pumping, because this water overhead tanks, elevated tanks are at higher elevation. We need to pump this water, and subsequently it will reach to the community. So this is the community water treatment system. Now let us look at how things will go in a household water treatment practices. So earlier in rural area, earlier in olden days as well as in rural areas, many people they go for the conventional practices of water treatment. The first thing what they do is when they collect water from a surface water body, what they do is they put a cloth filter, right? So the sediments, any impurities are there, which are suspended in nature, they will be separated on the cloth filter. Clean water comes out. So they used to collect it and then take it to the house. Then another thing is what they normally do is they go for boiling water in a small quantity. And then you see here some places they are using even this type of household sand filtration. Here we are using cloth filtration. This is a conventional sand filtration. Sand is used mainly as a filter medium. So you can see here sand is there and supported by some coarse sand and then gravel. So fine sand is mainly acting as the sand filter. The gravel is mainly the support for the sand. And then there are some slots at the bottom of the container. So you put the raw water on top of the sand, water will get filtered through the sand bed. It will remove some impurities, and clean water comes out in the bottom container. If you're having an outlet, then you collect the water from there. And during epidemics, and where bacteriological contamination is also there, particularly, so we can go for conventional systems for community. But household, how you are going to do? The first thing is by boiling, we can remove the bacteria. The other option is we can also go for some chlorinated tablets. They are available. So you take water, if it is not clear and contaminated with the bacteria during epidemics, then you add that tablet here and then wait for some time. This is what we call as a contact time, during which the chlorine or whatever it is inside the tablet, it will react with the water and remove all the microorganisms. And after the specific contact time, you can use that water. So these are the four systems which are generally used by the local people wherever they're using it, and they don't require any electrical power requirements. Now this is the modern systems. The modern systems, what we are having, you can see there are a number of candles are there. You call as a candles. Nothing but a filter beds or filter columns. So ultraviolet filtration is there, sand filtration, activated carbon. Everything comes fitted into this type of a small container. So this is another one, another model of that system. So where one is having a sand bed, activated carbon, and some other filter beds like this. So this is a container where water is collected after treatment. Now we are having an outlet here. You open the tap and then water comes out. You can see here also a tap is there provided. The treated water is stored at the bottom. So many of these they are directly connected through the overhead tank water. Nowadays, some portable systems are also coming here. So this is how some of the household treatment practices are being employed by the people. Community water supply systems, they are normally happening. So this is all about the water quality significance, components of water quality, role of role of environmental engineer, and then different types of treatment practices. Right? Thank you.